Welcome back to another Science Bros video. We're going to keep the trend going with some chemical reactions today, and we are going to do a little bit of an oxidation reaction and a combustion reaction. So here I have potassium chlorate, KClO3, that's its chemical formula. Potassium chlorate is a very strong oxidizer, meaning if we can mix it with something, certain chemicals that are going to have a lot of energy or potential energy, we can mix it with certain chemicals and we basically can actually get a nice combustion reaction. We can get a nice flame produced very easily. So in this case, my fuel is actually going to be a little bit of brown sugar. So if you look very closely here, what I have done here, and you can see a little bit of the brown in there, that is the brown sugar, and it is going to be mixed with the potassium chlorate, which is actually just a white powder. So we've mixed them in about equal parts, so it's about a 1-to-1 ratio by volume. And what we're going to do here is we're going to take a little bit of our potassium chlorate and sugar mixture, and we're going to set it down on this wooden block here, and we are going to see if we can get to something to happen here. So we're just going to use a lighter here as our ignition source, and let's see what we can get to occur. Hopefully this goes off without a hitch. All right, so let's talk about why this is happening here. So it just so happens that sugar actually has a lot of energy built into it. What I mean by that is sugar is made of a lot of hydrogen. If you know the formula for sugar, or sucrose, it is C12H22O11. So that H22, that has a lot of hydrogen there, and what is actually happening here is we can liberate that hydrogen, we can release a lot of energy, and if you know anything else about the formula there, what do you think this rest of this black stuff here that's left behind, if we're doing a combustion reaction, what should be left behind here if combustion reactions create CO2 and H2O? Well, that actually might be a little bit of pure carbon that is left there. So when we see the sugar reaction, we should see a little bit of pure carbon left over. So that is just a little bit of a reaction between potassium chlorate, our oxidizer, and our brown sugar here, and it produces a nice oxidation/combustion reaction. Now, I hope you guys didn't think that we were just going to do that once and call it quits. No, why do that? We made extra, might as well use the extra. So remember, this is our potassium nitrate and our sugar, our potassium chlorate in our sugar. And I got a little bit of extra here, and this time I want you to pay very close attention to the color of the flame that is going to be produced. Pay attention to what color flame you see here, and we'll just light this up. A little windy. Now, paid extra close, careful attention there, you will notice that it actually was a purple flame again. If you think back to our previous videos, was there any other time that you saw a purple flame? And you might think back to our alkali metal video when we actually took pure potassium and we put it directly in water and it ignited almost immediately, and you saw a little bit of a purple violet flame being produced. That's the same thing that we just saw right there, because remember, our oxidizer in this case is potassium chlorate. And potassium right there, we know if you have potassium in a compound, we are still going to get a little bit of that purple or violet flame right there. So that's a nice little fun fact as well. So I hope you enjoyed the video. Have a great day.